So now we will solve this last question of the Leetcode weekly contest 437, which is length of the longest V-shaped diagonal segment. So we are given a 2D integer grid and it's of size n cross m, and which have element that is either 0, 1 and 2. Now uh, we need to find a V-shaped diagonal segment, which is finite starts with 1. It always starts with 1, and then the subsequent elements follow this infinite sequence of 2 0 2 0 and so on. And the segment that starts along a diagonal direction, uh, top left to bottom right and all these directions, continues that sequence in the diagonal direction, and it can make at most one clockwise 90-degree turn. So these are the things that we need to keep in mind, and then we have to maintain that sequence. And similarly, uh, the maximum longest V diagonal segment you can come up with is you need to return the length, and if there is no one, then you need to return 0. Let's look at the examples, and we can see that the elements that the diagonal starts at 1, then it follows a sequence 2 0 2 0, and it took a maximum of one turn. So and we need to follow that same direction if we are not taking a turn. We are only changing a direction when we take a turn, and we can only do it at most one time. And as you can see here, same thing, we can always start with 1. So all the ones in this grid are a valid starting point, and the one with the maximum segment that can originate from it is the answer. So we need to make sure that. And also I can clearly see that there can be like multiple possibilities for each one. So as you can see here, for this one, for this we can either start from this direction as well, from 1 to 2, and again we can take a turn here, or we can also start from this direction, 1 2 0, you know. So there are multiple directions which from a single one which we can start from, and uh, the direction which gives the maximum length is the answer for us. So this kind of giving me a vibe for like recursion, so and dynamic programming, and how it is giving me that. So basically we need to find we need to for each element we need to find its the segment, and that segment can originate from another place. So that is recursive, because now we need, suppose we are this one, now I need to find a we are going through this 2, so now we need to find the maximum length such segment from this 2, starting from this 2, and then we go to this 0 and then again. So it's basically kind of like, you know, I'm at 1 and I'm asking, hey 2, do give me your best maximum segment, and what I will do is I will just add myself to it, and this way we have the greatest answer. And the similar thing, 2 will say to 0 that, hey 0, give me your best maximum segment, and I will add 1 to it. And similarly 0 will say to 2, and that sound, it goes until we find out that we cannot progress further. So this is a recursive pattern. And since let's take a look at the constraints. So the grid length can be at most 500, which is good for recursion, but I think we can also cache it. So there can be like multiple sub problems, which again gives us a hint for dynamic programming. So suppose from this one we can go from here too, but I can go also from this 2 to this above 2, and this above 2 I need to recalculate again if if I go to this too. So to save computation, I can store the results for all the two all the answers for the places, and then we can simply return. We don't need to recalculate them over and over again. We simply get it from the cache, so we can like cache the results, which increase the efficiency. So it gives me a depth first search algorithm. We can use that. And how we can use that is we first go through all the ones, and for all the ones we go through all the four diagonal directions, and we need to also maintain a way to track that. Okay, now we are one, so now with the next place we need to go is two, and the next place is zero, and then two. So we need to have some way to track that as well. And once that's done, we can like compare all the directions, all the four directions, which gives us the maximum answer. We will update it, and in the end we just return the maximum answer. So it's a depth first search, recursive, and we can also implement caching, so that can also reduce the time complexity. So let's take a look at the submissions. So our code starts from here. So first thing first, we initialize the result 0, so that we can like store the maximal length of the segment. We have calculated the rows and the columns. Caching part we will go in the end, so don't worry for that. And then we are going through all the possible cells in the grid. Once we encountered a cell with 1 in it, we know that we can start our segment from here. So after that we can go through in all the directions, and we maximize the result. So basically we have a result, and we have this function which is expected to give us the maximum segment for a particular you know uh, particular segment starting from 1 with a direction. So let me talk about the globals also. So here we have a global direction sector, which nothing but stores the how we are moving inside the cell in the four diagonal directions. So -1 will say that if we are at R comma C somewhere in the cell, so now it instructs us that you need to go -1 from the row side and -1 from the column side to reach this position. Similarly, -1 from the row side and +1 from the column side, you reach this position. So this just indicates all the four diagonal directions. And and then we have a next sequence. So this is a little bit complicated, but you can understand it. So basically each index represents what is the next sequence for that. So basically for index 0, if we are on 0 index, so as you can see that the next sequence for 0 index is 2. Similarly, for if we are on 1 index, the next for 1 is 2. And lastly, if you are at second index, so you are the next is 0. So this is the same thing. We just create a mapping with a list. I hope you understand this. If you're not understanding the directions part, I strongly recommend you to just pick a random, you know, this cell, and just try to mimic the rows and columns movements. with these directions, and you will find out. Then our this function expects a row and column, which is basically the cell position, the grid, the direction which we are uh, continuing, we what sequence we are on. So for all the starting sequence, the sequence will be 1, and then how many turns we can take. So as the question says that we can take at most 1 turn, so that's why we have initialized it with 1. And it's pretty simple. After the whole thing runs for all the direction, we are maximizing it, and in the end we're just returning it for all the positions. We are maximizing it here. Yeah. So this is the function which returns maximum segment length for a particular RC with a direction. And next sequence. So these are just the base cases for the recursion, and we will come to them at the end. So just forget about them right now. So now at each cell you have a two choices basically. Either you continue that direction, or you have a choice to take a turn. So this first choice indicates we are not taking turn, we are continuing in the same direction. That's why we can see that we simply just updated the directions, and we take the next sequence, and we the turns stay the same because we haven't turned, so the turn stays the same, and we are adding a 1 to it so that we can count itself. As I have told you in the starting, what our algorithm is trying to do is, let's say we are at this position, this one position, then we are saying to the diagonally 2 that, hey, give me my give me yours best uh, segment, maximum segment, and I will add myself to it. That's so that I can add 1 to it, and I will get my maximum segment. So this is what it is doing. So we are adding 1 so that we can like add ourselves. And the second choice here is indicates that we are taking a turn. We are taking a turn, and when we take a turn, we calculate the next direction. So this is the way we are calculating. So basically what we are doing is we have this 4 directions, and we are going this cyclic way. So 0 to 1, 1 to 2, 2 to 3, and 3 to back to 0. So this modulo 4 just ensures that we are in the cyclic nature. We just don't fell right outside the list. So suppose we are at this third index, so 3 plus 1 is 4, and 4 modulo 4 is 0. So we come back to this, and we will not go outside the fourth index because fourth index is not present in this list. So that's what we are doing, and here is the result. So again we are taking a turn this time, so we are updating the directions with the next direction which we have calculated here, and nothing special. We are just reducing our turns, so the next time our turns will be 0, and we will not be able to make a second choice. So this second choice will only trigger if you have uh, available turns left. So if you don't have turns, if you already made a turn backward, you cannot make a second choice. Then you are only there with the first choice, and we are maximizing it. That's it. So after that, we are returning the result, and so now let's, because if we left this here, the recursion will go into an infinite loop because we don't have a base condition. A base condition to stop this recursion is whenever we cannot progress further, it's the time when we stop. So any time when our row gets out of the grid, our columns get out of the grid, then, or if our grid row and column is not equal to the sequence next. So basically if I am at 2 and if I go to this 2, so basically I cannot go to this 2. It's an illegal move. You cannot go from 2 to 2. You have to go to a 0 next. So if you don't follow this, then we also stop, we return a 0. So returning a 0 means that we are backtracking, and that's it. That's how you do it. And now let's come with the caching part. So as you can see, I created a cache here. So what I am trying to do is I am trying to cache all the parameters, because these parameters are changing, and when they change, the results also change. So I want to uh, store these results so that I don't need to recalculate them for again and again. So I made a cache of R and C, row, column, direction, next, sequence, and turn. So this cache, uh, we store the result in the cache, and the next time when we are trying to call this recursive function, we first check if the answer or result is already in cache or not. So if it is, if yes, return the calculated one, or we can say in technical term memoized answer, and otherwise we will calculate it. So that's how we are doing it, that's how we are caching it. So this is a dynamic programming part of the recursion, and that's it. In the end you return the result. So this is the problem, this is how you solved it. And if you have any queries, drop them in the comment section. I will be happy to answer them. Thanks for watching. Bye bye.